Okay, guys, welcome to a new series. So, in this series, we are going to be looking at limit of functions. Okay, we'll be looking at two parts. Okay, one of them is going to be a theoretical aspect where we try to solve these things manually, see how they work, and then we are going to automate it as usual. If you've been watching some of my videos, you understand the fact that I love automating things to some extent. So, we are going to be using Python as a demo language. Okay, but that should be after once I've gotten the graphs of everything that we're going to treat. Okay, how to solve them. Now, using Python as a demo language, when it comes to that part, it is optional for you guys that don't want it. You can just skip through those videos and then move down to the next set of videos. Okay, so that's, guys, this is the first video we are going to be looking at on limit of functions. My name is George B. Smith. Okay, so let's start. So when you talk about a function, you have a function like this, f of x. And then what is the limit of this function? Talking about the limit of this function, you're looking at what this function actually approaches. Usually we say this function approaches something like L. Okay, but what is this function approaching as the value of x approaches a particular value a? So take note, when you say this function is approaching L, when you say this function approaches L, and you say L is the limit, this function can never get to L, as x can never get to a. So x moves very close to a, while f of x moves very close to L. That's one thing you have to know. So it moves close to L, it can never get to L. The same thing, x can never get to a. So they are just what their approach is. Okay, so usually we express this in the form the limit of f of x as x tends to a, that it's equal to L. That's meant to be a capital L, don't mind me. So it's equal to L. That's how we express that. Now, what do we actually mean by this limit? What does it actually entail? Now you see a function. Let me use an example. What should we call it? Let's say you have a function. You have a function like this. I have this as a function, and there's this particular point here. But I note where that if I have a value here, let's say this value here is a. Okay, as the value of x moves towards a, this function will be increasing. It will move far close to this, but it can never get to this. It will move very close to it, but it will never get to it. Let's say this is what I have as L. Same thing, this function can be moving from this part, and it will move very close to this, but it could never get to this. So you can see from the left and from the right, the value of x is moving towards a, while the function, this is a function, the function is moving towards L, but it is not getting to L. So this is what you call the limit of a function. This is diagrammatic or geometric representation of the function, of the limit of a function. Okay, so one other misconception when people say limit of a function, when they say x tends to a, some people take that the value of x should be increasing. Okay, it should be increasing towards a, but that's not the case. It could be decreasing. So I can say my x is 2, so I can have something like 1.9, 1.99, and the rest of them moving towards 2, or I can have something like 2.1, okay, let's say 2.01 and 2.1. so you can see here it is decreasing towards 2 this way. This is 2.1, this is 2.01, so it can be decreasing towards 2, it can also be increasing towards 2. That's the symbol, and that's what we say is the limit of a function. Okay, so one thing we have to notice is that the only time this limit will exist, because whenever you look for a limit of the function, it will either exist or it will not exist. The only time it will exist is when whatever you get belongs to the set of real numbers. If this does not belong to the set of real numbers, then it means the limit does not exist. But if it does belong to the set of real numbers, then the limit exists. Okay, so once you get any number, then the limit exists. If you get something like infinity or minus infinity, the limit does not exist. Now, there are different ways we can use to obtain the limit of a function. Different methods. The most common ones we see every day, they are by direct substitution, we have by factorization, we have by L'Hopital, which I like a lot because it covers for the second case, which is by factorization, and this last case, which is by rationalization. L'Hopital is general, it can work for all cases. Factorization and rationalization, they are not general methods, but this is a general procedure because it can work for virtually all cases of that any case, not all cases per se, all cases that factorization and rationalization can work, then all of L'Hopital would also be able to tackle that case. Okay, so that's it, guys. That's what you should be expecting in this particular part. After we are done with this, we are going to look at how we can get limits at infinity and some other kinds of limits we are going to look at. And also, we are going to carry out some proof on limits. Okay, so that's, guys, for this video, and I hope to see you guys in the next video where we are going to focus on limits by direct substitution. I'll see you guys in the next video. Bye bye.